So here we go with example 8 from chapter 8.5 on the mechanics. So usual approach, let's read through the question, pick out the key facts. A particle P is moving in a plane, time t seconds, its velocity is v, and the is 3ti plus it squared j. So we can tell that it's a vector context and that the acceleration is a function of t, so it's not su that. Yeah? So acceleration is a function of t, therefore not constant acceleration context. Okay, when t equals 0, the position of the particle is fixed with respect to a fixed origin O is 2i minus 3j. Find the position vector of P at time t seconds. So we've got to find the position vector. So we should know the relationship now between position, or R we usually use for that, sorry. So R, when we're talking about vectors, V and A. And when we're going in that direction, we integrate with respect to t, and this direction we're going to differentiate with respect to t. That's the key thing to remember. Okay, so we get v is equal to 3ti plus a half t squared j. And then when we integrate, so the integral of v, the position with respect to t, is equal to the vector r, which is equal to integral of 3t, well, write down the constant, add 1 to the power, divide by the new power. And we need a constant plus c1. And that's the I, plus, write down the constant, add 1 to the power, divide by the new power. And we also need a constant in the j component, so we'll call that C2. And that's the biggest difference. Yeah? You notice we need two constants, one for each component. Yeah? We need two constants, one for each component of the vector. So we can now use our boundary condition. So we're told at t equals 0, r, position relative to the fixed origin, so that's the bit from back here, yeah. The position vector of P relative to a fixed origin O is 2 minus 3, so R is equal to 2i minus 3j at t equals 0. So we get, if I consider the I components, I get 2 is equal to 3 over 2, 0 squared plus c1. So c1 equals 2. If I now think about the j component, negative 3, be careful with the signs. So the negative 3 is coming from here. Yeah, it's negative 3j, negative 3a, just to highlight it from before. We've also got 2i, so that gives us a 2. And that bit there was the I component. And now we're looking at the j component here. So we've got minus 3 equals a half of 0 cubed over 3 plus c2. Therefore, C2 equals minus 3. Right. Do not assume that when you put 0 in, that C2 is C1 or C2 is always equal to, in this case, C1 always equal to 2. Sometimes when you put 0 into a function, you get a value out. So for instance, cos of 0 is 1. That's something you already know. E to the 0 is 1. So don't assume that because you put 0 in, the constant will be 0. That's just not, sorry, the constant will be the value at the starting position. Okay, so substitute the values in, work it out every time, don't shortcut please. Okay, so that then gives us our answer. We can go back. R is equal to 3 over 2 t squared plus C1, which is 2 lots of I, plus t cubed over a half times a third is a sixth, plus C2, which is minus 3 lots of J. Do we have any units on this? Yes, meters. Okay, hope that's clear, and we'll move on to example 2.